Hi guys. Okay, so we are looking at the problems that relate to Charles' law, and Charles' law deals with the volume and the temperature relationships. If you increase the temperature, the volume goes up, and when you decrease the temperature, the volume goes down. And at a constant pressure, we observe this phenomena, and we see that this relationship is expressed as V1 over T1 is equal to V2 over T2. And that is the formula for the Charles law. So we have a condition here where a sample of a gas has a volume of 2.80 liter at an unknown temperature. So this is the initial condition, and now, when the sample is submerged in the ice water at T is equal to 0 degrees Celsius, its volume decreases to 2.57 liters. So this is the second condition. So you can clearly see that the balloon is inflated in the first condition when it was in a hotter environment. So the volume was more, but the balloon contracts and it loses its volume when the temperature goes down. So we need to find out what was the initial temperature, and if we know the values of the volumes. Okay, so we are given V1 is equal to 2.80, V2 is equal to 2.57, T1 is equal to, we need to find that one, that's our initial temperature, and the final temperature is 0. Always convert the 0 degrees Celsius to Kelvin, and that is by adding 273 to it. So that gives you the value of K. If you're not given 0 degrees Celsius, if you were given any other value of degrees Celsius, you still need to convert it into Kelvin. Okay, so now how do we do these conversions? So we write the formula V1 over T1 is equal to V2 over T2, and we identified that our unknown is in the denominator. So how do you bring all the known quantities on one side and the unknown quantities on the other side? So it's an algebraic conversion, but I'm just going to walk you through the steps. So if you look at it, that V1 over T1, and we need to bring T1 on one side of the equation and all the knowns, which are going to be V1, V2, and T2 on the other side of the equation. So what we're going to do first is cancel out T1 on one side of the equation. And that happens by multiplying by T1 on both the sides. So T1 multiplied here, T1 multiplied here. So we got now T1 on one side of the equation. But now we need to bring V2 and T2 on the other side of the equation. And technically they get reversed. But how do we cancel that out? So here we have V2 over T2 multiply by T2 over V2. So in other words, V2 and T2 cancel out, and T2 and T2 cancel out from one side of the equation. And on the other side of the equation, T2 over V2, you need to multiply that by V1. Okay, so now just rearranging, T1 is equal to V1 over V2 times T2. This is our equation. Next, we are going to just plug in the numbers. So we have now V1 is 2.80 liters over V2 is 2.57 liters. Okay, multiply these two by 273K, and this is our value of T1, and this comes out to be 297K. 297K. But now the question is also asking, what is the value in degrees Celsius? So how do you find that? So you just go back as we did. Degree Celsius plus 273 is equal to degree, whatever Kelvins come out to be. So in other words, degree Celsius is equal to Kelvin minus 273. So here we have the value of degree Celsius is equal to 297 minus 273. And here you're going to get 24 degrees Celsius. That is our answer. Okay, so I hope that was easy And thank you for watching. Bye.